No matter what profession you have, you need to know what tools are at your disposal to accomplish the job, right? And when you're building a network infrastructure, these are the building blocks that you'll end up using. In this nugget, I want to give you an overview of two of those, switches and routers. The most essential building block that you'll use for the network is known as the network switch, which is the central connection point for all devices plugging into the network. So let's say that you and I were into construction and we built buildings. We would put up the shell of the building and the drywall and the beams and everything else that goes into this. Obviously, we're not into construction, but you would eventually install the cubicles in the building for the people to sit at in the office rooms and the conference rooms and everything else. And you'd get to the point where you start installing the network jacks, because at each one of those cubicles and in each one of those offices, you're going to have one or more network devices. And that could be a computer, an IP phone, a video collaboration system, an Xbox, so whatever. There's all kinds of things that plug into the network nowadays. So you'd install these jacks, which then behind the jack would fish the cable up the drywall and in the ceiling, and all the cables in the building would eventually run to this one room that is known as the MDF, the main distribution facility, where all of the cabling terminates, and this is also where you plug in your network devices. So if we were to zoom into that room, typically in the corner of the room, you'll cut a hole in the ceiling, and all these cables from all these different jacks will come out of the ceiling. You'll have wire tie around them, so they're all nice and pretty, and those will go to a patch panel, which is really nothing more than a coupler. It takes the cable and you punch the cable into the back of that patch panel, and on the front of that patch panel is a bunch of network jacks, and we get these things known as patch cables, just short little Ethernet cables, which connect those network jacks into the switch itself, right here, which is actually a third generation device. Now, it wasn't always a switch. Decades ago, it was known as a hub, which is really just a device used to generate and repeat network signals. So let's just say that in this cubicle is a computer, and we install a server in this big room down here, and I want to send a message from this computer to that server. Well, again, if we have that, that wall jack and the cable going to the MDF and coming out here to all the different things, you would eventually have this switch right here, this hub, plugged into the computer, and let's just say, same thing right here, all the way down here, and the servers plugged into that port right there, right? If this is a hub, what happens is the signal comes in this port. The hub, which is just a simple, we'll call it a dumb device, receives the signal on that port and sends it out every single other port. So you're assured that the server's going to get it, but so is everybody else on the network. And that's bad from two aspects. One, think about security. You've got a evil person sitting in this office, because we hire a lot of those, and he opens a simple program like Wireshark, which allows you to see network traffic, and now he's able to see and actually reassemble a lot of the messages that you're sending to the server. Yikes, right? But the even bigger problem, because there's not that many evil people in our organization, although there's some, the bigger problem is that you're bothering every single device on the network. Right? They all have to get that message. They all have to look at it because it came in their port, and they have to say, oh, that's not for me. Now, if it's one message every couple minutes, then that's no biggie, but we're not talking about one. We're talking about thousands, tens of thousands, hundreds of thousands of packets, frames, messages that are coming in to this device, and every device is having to process. Now we've got a problem, because we're bogging down everybody's devices just simply by plugging them into the network. So hubs evolved into the second generation, and that is known as a bridge. So a bridge is where they added intelligence. The bridge can now look at the different devices that are plugged into it and learn their address, specifically their MAC address. That stands for Media Access Control. Every single device in the world has one that connects to a network. It's literally burned into the network card. It's a 12-digit address. It's hexadecimal, so 00A1BF7611. Oh, I didn't count my message. There we go, 111. There we go, 12 digits, and I said it's hexadecimal. That just means you can use the letters A through F as well in those addresses, and every device has one, and the bridge would learn all of those, and now became equipped with the power to filter those addresses, right? So the computer would come in, it would hit that port, and the bridge would learn what MAC address that was. And when that computer sent a message to the server, because the bridge would have learned all the MAC addresses, it would send it out just to the server. So now you're not bothering all of the network devices. You've increased your security, but the bridges had a fatal flaw. They were software based, meaning just like Windows or Mac, when you boot it up and it's loading, somebody wrote a computer program that essentially ran that bridge, and that slowed the whole system down because it had to load how to learn MAC addresses, and it had to load how to send MAC addresses out specific ports. And so eventually a very intelligent person came along and said, you know what? What if we turn those software functions into hardware functions? Because hardware can move as fast as the network cable can send. And so they built these things known as ASICs. And you'll want to know what that stands for because everybody slings this term around in the industry. It stands for Application Specific Integrated Circuitry. Essentially, it's a chip that translates these software functions into hardware functions so that it can move as wire speed. So this switch can now move as fast as the hub can, but it can intelligently filter the traffic and make our network a lot more secure and efficient. So ASICs are really good from that aspect, but have a drawback, and that is because they are hardware, right? What is easier to upgrade, hardware or software? Well, software, right? You just download a patch or a service pack or whatever the case is, and you upgrade that software and fix bugs and add functionality. Well, when you go with ASICs, now you've got hardware built into the device that the only way you're really upgrading it is to change out the device itself. So switches that are ASIC powered might not have as many features. And by the way, they have a lot nowadays. The ASICs have come a long way, and they've got a lot of functionality that are ASIC based, but they may not have as many features as a software based device. And I'm going somewhere with this. I'll tell you that in just a moment. These switches are typically 24 or 48 ports. That's the normal size that you buy. So when I say that, I'm talking 24 user ports. So if you count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up here will be 24. These over here are usually console ports, like this blue one right here that you use for management, or uplink ports like this guy right here might be used to daisy chain to another switch. Now, you can daisy chain anything. You can daisy chain those and daisy chain those, but Cisco just says, you know what? Let's just make it look cleaner. We'll have these ports that you might use for daisy chaining. Now I know you're like, well, that's a bummer. What about these? Well, these ports, and I know it's hard to see, I'm trying to tell, I think these are, but these are called SFP ports, where you can actually buy modules. So you can buy a little module that you slide in there and add another Ethernet port, because we need something to daisy chain to that guy, right? Or you can buy a fiber optic module, because fiber cable can run a lot farther than Ethernet cable can. So these adapt to whatever kind of media you want to plug into them. Those ports are in addition to the 24 or 48 user ports that you have over there. Now, some of these switches have this really sweet feature known as Stackwise, which if you flip the switch around in the back, looks something like that, to where you can have cables that are integrated into the switch itself that combine them together. Now, the cool thing is that this keeps you from having to daisy chain the front and use up your Ethernet ports just to connect your switches. But the even cooler thing is that this merges them into one. I don't know if you've ever seen Star Trek, you know, the episode with the Borg, where it's like the hive, the collective, the one brain that rules all of these little cyborg and Captain Picard, and it was awesome. The square thing that flies around in outer space, right? This turns your switches into the Borg, to where you have a central mind that manages them. When you now connect in to manage them, they are all managed as one device. Not all switches have that, but some of them do. Last thing I want to say before we flip on over to routers. These two icons down in there is how we represent switches in network diagrams, right? When you're drawing up a network diagram, it's painful to draw something that looks like this, you know, every single time you want to draw it up. So what people will do is they'll say, okay, well, this switch looks something like this, and we've got our computer connected into that, and our server is plugged in right there, you know, and then this switch connects to a router, which we'll talk about in just a moment. There are two different kinds of icons that you'll typically see for this. A layer 2 switch, which has the basic functionality that I talked about, where it learns MAC addresses and able to make intelligent forwarding decisions based on the MAC address table, also called the CAM table. Man, I'm just gushing with information. It's an overview, right? An overview of the switch. So it learns the MAC addresses, puts them into content accessible memory, or the CAM table, and is able to make intelligent forwarding decisions. The layer 3 switch has routing functionality built into it. Well, let's let that statement take us right into routers. Routers sit at the border of your network and do multiple things. So if I were drawing this in the network diagram, there's the switch. We've got all our, Bob Ross happy computers connecting into the switch, and there's our server and our happy trees. And this switch eventually connects up here to the router, and the router allows you to leave your network and reach another. Any guesses as to what the most popular network is? You got it. The internet. So the router brings the internet connection in, and you might be looking at these statements because it actually does two things. It contains the network, but also moves data between the network. How do you correlate those two things? Well, let me explain it this way. I have 6 kids that are 9 years old and younger. It's crazy at my house, right? And sometimes my wife goes out in the evening and leaves me with the kids, and it's like dad's rules come into play, right? And dad's rules is dad sits on the couch and reads or works on his computer or something like that, and kids go play, right? And as you can imagine, with kids, 6 of them that are 9 years old and younger, I don't get much couch time, right? It's usually, they're playing for a while, and then, hey, he took my, and then shoom, something flies across the room, hits the 2-year-old in the head, he falls over, and before long, it's just complete chaos. And there's times where I'm, I've got all these little kids that are, Lego knives and things like that. And I'm just like, and I just kind of shove them all in the room, and I close the door. I'm like, do not come out until you figure, obviously the good parent that I am, don't call CPS on me or anything like that. But what I've done is I've contained the madness, right? All the kids are in the room. They're like, and I can now come back out to my couch, and I'm in denial. That's not happening right now. I'm just going to use my laptop. And the way I work this thing is I'm like, hey, if one of you want to come out and you want to tell me what's going on here, because obviously the mature parent that I am, I can figure all this out, right? You can do that. So this is how the router works, right? There's all kinds of chaos going on the internal network. This guy's trying to chat with this guy, sending ARP broadcast messages, bothering the whole network. It's all chitter chatter. Most of the stuff that just belongs inside. And the router actually blocks all of that. Technically, it blocks all broadcast traffic. It's like, keep your mess over here inside of the network. But if you've got somebody, right, that specifically wants to get to, let's just say, Google, out here on the internet, then come ask me, come talk to me, and I can move you directly between the different networks. That's known as a unicast message, a one-to-one. Like, I just want to take my computer and I want to talk to that server out there. The router can help you with that. And I'm getting, real broad because this is just a broad brushstroke of the functions of this. So in a way, it adds a little security, right? Because all of your stuff, private stuff that doesn't matter and private stuff that does matter, stays behind here, right? Because it's all just chitter chatter being blocked by that router. But the main thing that it does is allow you to move traffic that belongs between the different networks. Now, this little gem also allows you to connect dissimilar networks. Look at this picture right here. This is actually a picture of, what is that, a 1905 router. Now, on here, you'll see a console port. Use that for management. And an auxiliary port. Use that to connect a modem if you've got one of them. I mean, nobody uses the aux port anymore. But over here is, first off, 2 Ethernet ports. If I know it's super small, but if we zoomed in, you'd actually see GE0/1, and this one down here says GE0/2, or 0/0. That stands for Gigabit Ethernet. Module 0, port 0. We'll talk about the labeling in just a second. But this guy, just looking at it, has 2 gigabit Ethernet ports. One that would probably plug into that switch that we're just talking about. One that maybe connects up to, let's just say, a cable modem. Here's your little cable modem or DSL connection that has an Ethernet port, and it can route between your internal network and the outside world because that cable modem connects out to the internet. But maybe you have another connection type. This is actually known as a serial connection. When somebody says, hey, I've got a T1 line, or you might have heard of things like a frame relay or ATM, or there's all kinds of different network types that need these kinds of connections. These could be a serial connection to maybe a WAN provider, a wide area network provider that allows you to connect to some other offices, not just the internet. This could be an internet connection as well, but it's flexible. Switches don't have serial ports. They don't connect dissimilar networks in that sort of way. They only have Ethernet ports. So the router has a unique functionality there. Now, the other piece of a router is that it is software-based and feature-rich. Now, take what I just said about the switches with the ASICs and hardware and all that kind of stuff. Yes, a router is slower than a switch, but as a trade-off, I mean, nowadays it's really fast, but at the same time, as a trade-off, you get all kinds of features in every new iOS version that you install. That was actually originally Cisco's term. It's not the Apple iPhone. It's the Internetwork operating system. Every new Internetwork operating system upgrade that you add to that router adds new functionality and bug fixes and all that kind of thing without the need for ASICs, because ASICs belong in the switch world. So when I talked about having a layer 3 switch previously on the slide, yes, there are switches that can also do routing. However, their functionality will never reach, well, I won't say never, but it will be a long time before the functionality of a switch can reach the level of a router, because the router has the advantage of having all kinds of software functions added to it. Well, those are the two most essential building blocks of the network infrastructure: switches and routers. They call it CCNA routing and switching for a reason, right? So in an upcoming nugget, we're going to talk about the wireless access points and firewalls and so on, but that should give you an overview of where switches and routers fit in the big picture of things. I hope this has been informative for you, and I'd like to thank you for viewing.